Hello, I'm here to talk to you about the differences between project-based learning and problem-based learning and give you a case study of how this might be used within the classroom. I'm going to start with project-based learning. The definition of project-based learning from the Buck Institute for Education is that students gain knowledge and skills by working for an extended period of time to investigate and respond to an authentic, engaging, and complex question, problem, or challenge. The picture that you can see here on this slide is actually a picture from my classroom with my students developing cranes. We were testing to see whose crane could hold the most weight, and they were exploring the strength of different shapes, triangles, squares, rectangles, to see which of their ideas or designs could hold the most weight. There's also problem-based learning, and the definition of problem-based learning from the University of Delaware is that in a problem-based learning model, students engage complex, challenging problems and collaboratively work towards their resolution. Project-based learning is about students connecting disciplinary knowledge to real-world problems. The motivation to solve a problem becomes the motivation to learn. And you can see here in this picture example that these students are working together to solve a problem. I am now going to talk to you about a case study of an agriculture and transportation lesson that I use in my classroom. I primarily teach 9th and 10th grade students in an engineering style tech ed class. It is a graduation requirement for all students, and they all must pass my class in order to graduate. So we start this lesson in my class by taking notes the old-fashioned way, pen, paper, PowerPoint. This ensures for me that all students have the same level of background knowledge. They all have a definition of transportation. They all have a definition of agriculture. They know the difference between primary and secondary harvesting and what the modes of transportation are. And I give them a couple of examples of how the two have come together to improve both and how they are both kind of reliant on each other at an incredible level. And so we talk about combines and grain elevators and conveyor belts. Then the students go into a project or problem-based activity. Primarily, I tend to go for the project-based activities. In my classroom, my kids love the hands-on, the getting dirty, the let's figure this out type of activity. I have done a problem-based activity in the past, and I'm going to share both of those ideas that I use with you on the next slide. The way that I would assess this lesson comes in 3 ways. This agriculture and transportation lesson comes as a part of a larger unit within my curriculum that looks at all of the different types of technology. So we talk about manufacturing and production and construction, biotechnology, and also agriculture and transportation. So the assessment comes in 3 ways. First, there's some sort of formative note-taking exercise. And that could be that the students hand in an exit ticket for me, or I collect their notes to see what it is that they wrote down. And the students in my class know that I can do it either way, and so that they have to be prepared for both. Then I have 2 summative assessments. The first would be the rubric for the activity that's directly related to this lesson. Whether project or problem-based, I always use a rubric. The other summative assessment is our unit test, which would encompass all of the different aspects of technology that I mentioned earlier, as well as agriculture and transportation. So the 2 options that I choose from for this lesson are either a research challenge that can take the form of a presentation or a debate. I've done it both ways. And then also a maglev race, where the students build and test maglevs. I'm going to talk first about the problem-based learning option, which is a research challenge. And the students would get into groups, depending on the maturity of the class. Depends whether they get to choose their partners or work in groups that I assign. And they would research a real-world issue that faces us, something in the news or something that might not necessarily be in the news but should be. And so those topics can range from alternative fuel sources like biofuels and nuclear energy and hydroponic technology of using water to generate electricity, or some students will look up GMOs and cloning and cellular reproduction in different aspects, anything that deals with transportation or agriculture or both. And then the students would develop a solution or a potential fix to this problem. I always tell the students to imagine, if we go with the presentation route, that I'm Congress and they have to present their idea to me as if they were trying to get a bill signed into law to allow the production of their solution. I've also done this as a debate where I have students as the expert panel, the ones that did the research, and then they debate with the common citizen or the students that did not do research in their specific topic. And so they can kind of get a feel of how it feels to be the educated person and how it feels to be the uneducated person, and how our personal opinions can alter the way that we understand and see a topic. The project-based learning activity that I do is a maglev race. Maglev stands for magnetic levitation transportation. And so it uses the idea of positives and negatives don't like each other very much, and so they repel, which allows this vehicle to float down the train tracks. And they're used very heavily in Asia. In fact, China has the longest maglev passenger track in the world, and there's actually hopefully one going in when money comes through that will link New York and DC. And they are some of the fastest vehicles in the world. They can theoretically, if that track goes in from DC to New York, you would be able to travel between the two of them in 30 minutes, which is pretty amazing considering it's a 4-hour drive right now. But the students create these maglevs using just basic magnets that we glue onto the bottom of these vehicles that they make out of recycled materials. And their vehicles must be able to transport an agricultural load. And so I take some pinto beans and I measure out 2 ounces worth of pinto beans and put them in a little baggie. And their maglev must successfully carry the load from one end of the track to the other without losing it, because we don't want our trains to crash at the end and the beans to go flying. But they also must beat the partner group that they are racing against. And so it gets to be very competitive and very fun, and the students get a real good kick out of seeing who has the fastest maglev, and I normally award some kind of extra credit for that. But they go through the motions. They use all the recycled materials from the leftovers of the projects that we have done for the previous parts of the semester, and they work together in partners to first build something that is aerodynamic and then also build something that will float. And the floating is the most difficult part for my students so far, but they seem to have a lot of fun with that. And then obviously both of these options would be graded or assessed by a rubric, which looks very different for both of them. The problem-based learning rubric deals more with their presentations as opposed to their research, and then the project-based learning rubric looks more at their planning process and then their analysis of their design and that metacognitive process of how would I fix my problems. So both incredibly important aspects, but 2 totally different rubrics. I hope that this presentation helps you understand the differences between them, and if you have any questions, please feel free to contact me.